Question 1. Find the highest common factor of 140 and 245. So we're looking for the largest number that 140 and 245 can be divided by. To start, recommended method is to break these numbers down into prime factors using a prime factor tree. So 10 times 14 makes 140, 2 times 5 makes 10, they're both prime, 2 times 7 makes 14, they're both prime. Do exactly the same with 245, gives us 5 and 49 with 5 prime, and 49 becomes 7 and 7, both prime. There's two ways you set this up in terms of figuring out your highest common factor. The Venn diagram method involves you placing these prime factors in a Venn diagram, where you start off with what's in common. So in common here we have a 5 and a 7 is going to go in the middle. We're then left with 2 2s in the rest of the 140 circle and a single 7 left in the 245. Our highest common factor is then the multiple of all the values in the overlap in the intersection. So we have 5 times 7 here, giving us 35 as our final answer. The other way of doing this is the what loses method, where we write each of these numbers as the product of powers. So 140 is 2 times 2 times 5 times 7, or 2 squared times 5 times 7. 245 is 5 times 7 squared. And then we're looking at each of these numbers one at a time and seeing what loses, what's the lesser amount of prime numbers. So we have no 2's here, so we have none of them are going to be involved in our highest common factor. Doesn't matter which of these we pick, we have a single 5, and then out of the 7 and the 7 squared, the 7 loses, which gives us a 5 times a 7, exactly the same as here, with exactly the same answer. Part B, we have a machine that has a buzzer that sounds every 50 minutes, and we have a bell that sounds every 80 minutes. We will take into the consideration the time in a moment, but basically this is a lowest common multiple question, a applied version of it. So at its core, you're trying to find the lowest common multiple of 50 and 80, and then we'll deal with the time situation afterwards. Now, more than one way of doing lowest common multiple. One of the methods is to break it down into prime factors, similar to what we did before, except new step afterwards. So we get the following, just breaking these down into prime factors again. It's going to be 2 and 4, then 4 becomes 2 and 2. And then when we have two options within this option. We have a Venn diagram again, where we place all the numbers in, except this time, when we're dealing with the lowest common multiple, we are not just interested in the overlap, we are also interested in the numbers that are left over. So we have a single 2 and a single 5 there. We have 1 5 left over in the 50 part of the circle. 50 part of the circle, and then we have 3 2's spare for the 80. The lowest common multiple is everything in the Venn diagram multiplied together. So we're going to have a 5 times 5 times 4 2's, and from that we get the number 400, which is not the final answer, so I should stop that. We have 400 as our, not HCF, as our LCM. That is one method of doing it. The other way, which uses the prime factor tree here, is what wins. The what wins method. We're looking for the biggest 2, the biggest 5, so on and so forth. So from 50 we have a single 2 times 5 squared, and from 80 we have 2 to the power 4 times 5. Looking at these here, we have a 2 to the power 4, which is the largest 2, and just linking it back to this, there was another 2 here that I've accidentally deleted. There are 4 2's being times together there, and then out of the 5's, the 5 squared wins, which is this 5 times 5 here. So either way, you're going to get 400 from that. The other method is to write out the times table. If you've got a lowest common multiple, you just start writing out the times table of each number and keep going until you get the same number on each list. So starting off those lists, if I kept going, the first number that I will see on both of them that they share is 400, making that the lowest common multiple. So this 400 is in the form of 400 minutes because of the fact that the 50 and the 80 in the question refer to minutes. And the buzzer and the bell sounded at the same time at 10 a.m. So we're looking for 400 minutes later than 10 a.m. 400 minutes, if we convert it into hours and minutes, we get 6 whole hours with 40 minutes spare. So we are going from 10 a.m. forward in time 6 hours. If we write this as 24-hour time, that will give us a 16, followed by 40 minutes. Or if you prefer to write this in 12-hour time, we can write it as 4:40 p.m., bearing in mind you must have p.m. along with that 4:40 in order to get full marks.